Hello everyone. So in this video, we'll be discussing lines. So lines is under analytic geometry discussion, and we'll start with the discussion of the distance formula. So the distance formula is given by this equation. We have d is equivalent to square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And we also have the midpoint formula, which is given for the x coordinate. We can get the midpoint of our x by adding two x's or two values of our x and then divide that by 2. So that is the how we get the midpoint of our x, and it is denoted by this symbol, the x with a bar sign. And we also have the y coordinate, which has the same process of getting the midpoint of our y. We have to add the 2y and divide it by 2, and then we have this symbol. We have the y with bar at the top. So for example, we have find the distance and midpoint between -2 and -1 and 4 and 3. So that being said, if we try to graph that one in our Cartesian plane, so we can have 1, 2, 3, and 4. We can also have 1, 2, and 3. And we have the -1 and -2. And we also have a -1 here. So if we try to graph this set first, the data points of this one, -2 and -1. So meaning to say this one is our x and this one is our y. So -2 is found here and -1 is found below. So that being said, if we try to graph that one, that is found here. And for the second set, we have 4 and 3. So that is, this is the +4 and this is the +3. So if we try to um, graph that one or plot that one to our Cartesian plane, that is located somewhere in this point. So let's try to connect the dots here, connect the dots to form a line. So that is given by this line. So from this one, the problem wants us to find the distance and the midpoint of these points. So meaning to say, we need to find the distance between this point. So this one is the distance. And we also need to find the midpoint of the x and the y. So in order for us to find the d and the midpoints, we can follow this formula here. So we have d is equivalent to x sub 2, in which our x sub 2 is given to be our 4, minus x sub 1, which is 2. And since that is negative, let's just erase this one so that we won't be confused. So again, this is our x sub 1, this is our y sub 1, this is our x sub 2, and this is our y sub 2. So substituting that here in our equation, we have x sub 2 minus x sub 1, which is our x sub 1 is -2, so that gives us +2 squared. And we also have plus y sub 2, which is equivalent to 3, minus our y sub 1, which is -1, so that becomes +1 squared. So if you calculate this one, our distance is equivalent to 4 plus 2 squared plus 3 plus 1 squared. That is equivalent to 2 square root of 13, or approximately equivalent to 7.25. 21. So meaning to say, this distance here, the distance between the 2 points is 7.21 or 2 squared of 13. Now, we need to find now the midpoints of our x and the y. So in getting the midpoint of our x and the y, we have x bar is equivalent to x sub 1, which is negative 2, plus our x sub 2, which is 4, and divide that by 2. So we have negative 2 plus 4 divided by 2, that is 1. So meaning to say our midpoint of x is at 1, and the midpoint of our y is equivalent to y sub 1, which is negative 1, plus our y sub 2, which is 3, divided by 2. So that gives us the result of 1. So meaning to say our midpoint of this line is here, since this is the x, this is 1 and this is 1. So meaning to say our midpoint is at this point. So now let's move on to another example. We have here the point 0, 1 is the midpoint of a line segment joining x4 and 3y. We need to find the x and y. So how can we solve this one? So in order for us to solve this equation or to solve this problem, since this is requiring us to find the value of our x and the y, so we have the x and the y here. So if we try to graph the given points, we have here, it is said that the midpoint is 0 and 1, so meaning to say that is somewhere here. So this is the midpoint. What we need to do is we need to find the value of x and the y so that we can graph and check that the midpoint is in 0 and 1. So from that, since we know that the formula of our midpoint is, for the x, we have x is equivalent to x sub 1 plus x sub 2 all over 2, right? So this is our midpoint of x, and this is our x sub 1, and negative 3 is our x sub 2. So we can try um, substitute that to our equation in order for us to find the value of our x. So we have 0 is equivalent to x, which is the unknown, plus our x sub 2, which is negative 3. So we can just change that one to minus 3. And that is divided by 2. So in order for us to solve or isolate the value of x, we can multiply both sides by 2. So we can remove this denominator here. So 0 times 2, that is still 0. So we have equivalent of x minus 3. So from here, we can already find the result of our x, which is equivalent to 3. So meaning to say, this one, the value of the x here is equivalent to 3. Now, we need to find the value of our this y. So from the midpoint that is given, we have the formula y sub 1 plus y sub 2 all over 2. Now, midpoint of y is given to be 1. So we have 1 is equivalent to y sub 1, which is 4, plus the unknown y, this one, and then divide that by 2. So same process, multiply both sides by 2. So we have 2 is equivalent to 4 plus y. Now, in order for us to isolate the value of y, we need to move 4 to the other side of the equation. So we have 2 minus 4 is equivalent to y. Now, 2 minus 4, that is negative 2. So that is equivalent to y. So meaning to say this y here is equivalent to negative 2. Now let's try to graph our points. So we have 3 and 4. That is 1, 2, 3, and 4 is 1, 2, 3, 4. So let's just erase this one. So we have this one is 3, this one is 4. So that is somewhere in this area. And we also have negative 3 and negative 2. This one is negative 2. So we have 1, 2, 3, and we have 1 and negative 2. So the last point is somewhere here. Now, as you can see, if you can assume that this is a straight line, then you can really check that the midpoint, that the answer that we got is correct. So we have the slope of a line, and the slope of a line is symbolized by the letter M, which is the line is the tangent angle of inclination. M is said to be equivalent to tangent of theta, which is mostly called as the rise over run, or the change of y over the change of x, which is given with this equation: y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So for example, we have here, find the slope of the line that passes through the points 1 and 2 and 3 and 4. Now, in order for us to find the slope, we can directly solve for that using this formula. So we have m is equivalent to y sub 2, which is 4, and minus our y sub 1, which is 2. So we have here, and then x sub 2, which is 3, minus our x sub 1, which is 1. So if you try to solve this one, we have 2 over 2, and that is equivalent to 1. So meaning to say, the slope of our line, or the slope of the line, is in equivalent to 1. So let's try to graph this one in our Cartesian plane. So we have first point is 1 and 1, 2, and we have 3, 2, 3, we have 3 and a 4. So let's try to graph that one. 1 and 2, that's found here. 3, 4, that is found here. So the slope of this line, or the angle of this one, is said to be, the tangent of this one is equivalent to 1, the slope of our line. Next that we need to discuss is the equations of the lines. So there are many types of the equations of the lines. So the first one is the 2-point form. So the 2-point form is given to by this equation: y minus y sub 1 is equivalent to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 multiplied by x minus x sub 1. So we also have the point slope form, which is given by the equation y minus y sub 1 is equivalent to m times x minus x sub 1. So from this, given this, we can have our example. Find the equation of the line passing through the points negative 2 and 1 and 3 and 4, and draw the line. So from this one, let's try to solve first using the 2-point form. So y here is just as is. Then you need to substitute the values to y sub 1 and y sub 2. And x as well is as is, because since you are looking for the equation, you are not looking for the constant result. So let's try to substitute the values that we have here. So again, this is our x sub 1, this is our y sub 1, and this one is our x sub 2, this one is our y sub 2. So let's try to use two-point form in finding the equation of the line. So we have y minus y sub 1, which is equivalent to 1, is equivalent to our y sub 2 minus y sub 1. As you know, as you can see, point slope form and two-point form is just the same, because if you can notice, this one, the equation enclosed by the parenthesis is the equation of the slope, right? So basically, they are just the same. M is equivalent to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So they are just really the same. So y sub 2 is 4 and y sub 1 is 1 all over x sub 2, which is 3, minus our x sub 1, which is negative 2, so that's plus 2. And we have the x minus our x sub 1, which is negative 2, so we have plus 2 again. So we have y minus 1, and then we need to calculate this one, that's 3 over 5. If you calculate this one, that is 3 over 5, then we have the x plus 2. So in order for us to eliminate the fraction, we just have to multiply both sides by the denominator, which is 5. So we have 5y minus 5 is equivalent to 3 times x plus 2. Now, in order for us to find the equation of the line, so we'll just distribute our 3, so we have 5y minus 5 is equivalent to 3x plus 6. Now, combining this one and then equating this one to 0, we have 5y minus 3x minus 5 minus 6 is equivalent to 0. So we have 5y minus 3x minus 11 is equivalent to 0. So this is now the equation of our line. So meaning to say, if we try to graph this one, let's try to graph the points in our Cartesian plane. We have negative 2 and 1. So we have negative 2, then that's 1. So it's somewhere here. And we also have the 3 and the 4, which is 1, 2, 3, 2, 3, 4. So that is somewhere here. And it is said that the equation of this line is equivalent to 5y minus 3x minus 11 is equivalent to 0. Also, that is equivalent to 5y minus 3x is equivalent to 11. So that is just the same. So this is now the equation of our line using the two-point form and the point slope form. So that is how we get the equation of the line. Next is the equations of lines. The next part, or the next equation of the line, is the slope-intercept form. So from here, we have the slope-intercept form, which is equivalent to this equation, y is equal to mx plus b. So if you see this kind of form, that is what we call the slope-intercept form. For example, write the slope-intercept equation of a line which passes through 0 and 4 and 3 and negative 5. M here is the slope, and B is the y-intercept, And in order for us to determine the y-intercept, that should come in this form. We have 0 as our x, and b is the y-intercept. So from here, if you can check the data points or the sets of points that is given here, you can see that this one is our b, because this -5 cannot be our b because the x that comes with it is not 0. So you need to choose your b. If you can directly choose your b if the x that comes with it is equivalent to 0. So that is how we easily identify what is our b. Now, again, we need to write the slope-intercept form using these points here. But we don't have the value of our slope yet, so we need to solve the slope first. So we have m is equal to y sub 2, which is -5, minus y sub 1, which is 4, all over x sub 2 minus x sub 1. So our slope is equivalent to -5 minus 4, and that is divided by 3. So meaning to say our slope is -3. So we already have the result of our slope. So substituting that to the intercept form, slope-intercept form, so we have it, y is equal to -3x, and our b is 4. So this is now the result of our equation. This is now the equation of the line in slope-intercept form. Next example is, what if we don't have, what if we don't have the b? How can we get, or how can we solve for the b if the example here is given to have -1 and 4 in the slope? Now in this case, the slope is given but b is not given. So still using slope-intercept form, again we have y is equal to mx plus b. So how can we solve for the value of b? So from this one, we can just solve for the value of b by substituting all the values that we have here to our equation. So 4 will be substituted to y, and -1 will be substituted to our x, so that we can isolate the value of b. So we have 4 is equal to 3, and we have the x, which is -1, that is plus b. So we have 4 if equal to -3 plus b. Now moving this one to the other side, so we have 4 plus 3 is equal to b. So meaning to say our b is equivalent to 7. So we can already find the equation of the line in slope-intercept form, since we already have the value of our b. So we have y is equal to m, which is 5, x plus 7, which is our b. So this is now the equation of our line in slope-intercept form. The next equation of the line is the intercept form. So the intercept form is given by this equation, or by this format. We have x over a plus, this should be y over b is equivalent to 1. So for this one, a line has an x-intercept of 6 and a y-intercept of 4. We need to find its equation. So basically, you can just plug in the value of 6 and 4 to our a and b, and then you can already get the equation of your line. So we have x over 6 plus y over 4 is equivalent to 1. So that is already your intercept form equation of your line. So that's it for this video. That's it for the lines. That's it for the discussion of the lines. So I hope to see you on my next video. Please don't forget to like this video, and thank you. Have a great day.